in addition to the style rules being editable, you can actually also edit the selectors. So here we're currently applying this, this rule to a body tag. Let's add in a div as well. And you can see those divs will now be colored with a pink background. So that doesn't look so great, so I'm going to remove that. All right, so next we have the box model values that are being calculated for the element. And these can also be edited. Body isn't necessarily a great example of this. Then next we have all the JavaScript properties of each DOM node. So the JavaScript engine is wrapping a JavaScript object around each node, and then here we can see all the properties that are applied to those nodes. And you can see there's going to be a ton of JavaScript properties for each of the nodes. And then finally, we have any event listeners that are applied to the node. In this case, the body tag has no event listeners. If we select this node here, this probably does have an event listener. You can see there's an event listener being applied to the input. If you navigate down here, you can ultimately see the function that's being called. This is quite small. I can't even see it. So here you see the function jot underscore set text, etc., etc. Can you guys see that okay? That's being called when that event is fired. So that covers the elements panel. Next, we're going to go to the resources panel, and this is turned off by default because it is resource intensive, but I'm going to enable this. And I'm going to reload my page here with a slight difference. So right now I'm on www.chromium.org/devtools. I'm going to switch that to just chromium.org. And the reason I'm doing that is because this page is running on Google Sites, which requires the www CNAME. I want to show you what happens by forcing a redirect here. So I'm going to reload that. And let me make this panel, or this window big. All right, so what we're looking at here is a timeline of all the resource loading for the page. And there's a ton of different ways that you can filter and slice and dice the data on this page. But let's look at the default way, which is quite handy. So we have a timeline. Here's our 0 seconds or 0 milliseconds, and it's going all the way up to 2 seconds when the page is finally finished being loaded. And then we have a list of resources that are being loaded for the page. So this first one should be the redirect that I forced. And you can see that this is just a header. And here's the URL that we requested, chromium.org/devtools. And we got back a 301 redirect. And it pointed us to a location of www.chromium.org instead. So that should be this next resource here. And if we look at the headers, we can see that we did make that request to the www page. We got it back at 200 OK. And so we have the actual HTML content of the page. So the rest of these resources are going to be things like JavaScript, style sheets, images, any sort of Flash movies, and what have you. And if we look down here, you'll notice that some of these have a transparent portion as in addition to a filled-in portion, some of these resources. The reason for that is that the transparent portion represents the time that the browser was waiting for the server to respond, and the filled-in portion is the time that it actually took to transmit that data. So we also have another prominent view on this page, which is that you can view the resources by size. And here the transparent versus filled-in difference takes on a little bit different of a meaning. So if a resource has a transparent portion, that means that it was compressed in transmission. So the filled-in portion is the compressed part that was actually probably gzip, that was actually sent over the wire, and the transparent part is the uncompressed full resource. Is there a question? All right, next, let me go back to docking this. So we'll look at the scripts tool next.
Oh, I'm sorry, no, we're in the resources.
Yep.
Is there any notation for cached resources, or does this automatically uncache and cycle everything in new?
So everything is being cycled in new. You can see elements that are being cached in I believe, the timeline, which I'll show in a couple tools over. Okay, so the scripts panel next. So I'm not going to talk about this too much because I'm going to get into it more when we go through debugging JavaScript. But what I'll say here is that, so we have, first of all, our actual source code in the main panel here. If a page has multiple JS sources, you can toggle through them up top here. And then we have, in our secondary panel here, we have a bunch of instrumentation, which I'll talk about more when we start debugging. So this is a pretty typical debugger. You can set breakpoints, do pause the script execution, and that sort of thing. Okay, so next we have the timeline. And I'm also not going to talk too much about the timeline and profiles because I'm going to show them more later. But what both the timeline and profiles allow you to do is to record the loading or execution of your page. And we'll sample the page at a rate of 1,000 samples per second and show you where your page is actually spending its time. The timeline tab deals with all the sorts of main places that your page is going to be slow or just generally spending its time. So it deals with the loading of resources. It also deals with the execution of JavaScript and the rendering of DOM. The Profiles tab lets you dive in specifically on the JavaScript execution. So you can actually think about the resources, timeline, and profiles as three parts of a whole. So timeline is basically the overview. It lets you see all three things, like I said, loading of resources, JavaScript execution, DOM rendering. Resources lets you really zoom in on the loading of resources, and the profiler lets you really zoom in on the execution of JavaScript. Again, the timeline and profile we're going to look at in more depth when we get to these case studies. Next we have storage. So this gives you all the offline info about your page. So for most typical pages, this is just going to be cookie information, which is the case in this page. So we're actually looking at something a little more than what you get with if you ran like document.cookie. This is actually the live cookie store for this page, so you can actually go in and delete these cookies and it'll permanently remove them from your browser. We also have this app cache thing, which I actually haven't seen before. I guess it's brand new and since I have this tip of tree version of Chrome. And we have things like HTML5 databases and places for local storage and session storage. So since this page doesn't have any of these things, I'm going to open a new page that does. And I'm going to navigate over to html5rocks.com, which is this HTML5 site that we recently launched. How many of you guys have seen this, by the way, HTML5 Rocks? Okay, cool. It's we have lots of tutorials and just general goodness about HTML5 on here. So this is a tutorial about creating a persistent to-do list. It'll keep your to-dos even when your browser shuts down using the Web SQL Database API. So I'm going to scroll down here and open another DevTools panel here.
Which one is application cache? That's not local storage and Web SQL, right? It's something else.
Yeah, so I actually don't know much about app cache, but I see Paul back there. Paul, do you want to do a quick word about app cache?
App cache is a way to basically hold any sort of resources, whether typically you'll hold images and probably the HTML page that you're looking at, and hold that in an offline database so that when you do go offline, you can still access those things. So that's the common use for app cache, but you can also use it just to speed up the site. It's like an alternate version of caching. So.
question.